The company in 2008, the founders of the company actually previously did a startup called DCT. And DCT was notable because they built software in the deduplication space. And it was acquired by Veritas, which then, of course, was acquired by Symantec. But the core team of people that founded our company worked on net backup for years. So they were part of the core development team on deduplication. What they thought about in 2005 was a data protection technology under the heading of what people are calling erasure coding. So this is really a RAID alternative. They kind of saw this wave of big data coming, and they realized that with people wanting to store petabytes and beyond of this big data, what we really needed to do was to provide a very cost-effective way to protect that for longer periods of time. And I'm not sure if you know this, but RAID technology is sort of the established way of protecting data on disk. And it works very well, but as drives get bigger, it suffers a problem, which is that when one of the drives in a RAID group fails, you have to rebuild it. And the rebuild time can take much longer, of course, as the drives are bigger. So what we were starting to see was that rebuild times, which used to be 20 minutes, were now taking a day or more, right? And so as these drives are becoming 3 terabyte, 4 terabyte, it's possible we'll start seeing week-long rebuild windows. That's a problem because it means that you have an exposure to data loss. If you have something else happen while you're rebuilding, you'll lose the data. But moreover, systems are getting so big that you can have rebuilds happening all the time. So that hits performance. It makes the administrator work harder because they have to go and figure out where things are breaking. So ultimately, we said there's got to be a different way to do this. And that's what we started developing, was a software technology that was able to protect data to very high levels on big drives. Okay, the industry has experimented with this type of technology before. In fact, it goes back to the 60s, the notion of erasure coding. It was actually used in deep space transmissions, right? So if you had satellites going into space, you wanted to be able to send them data packets. But if a few of them got lost, you still wanted to be able to have the satellite read the transmission. So that's the notion of erasure, right? You can lose pieces or erase pieces and still read the data. People started applying that to data storage with optical media back quite a while ago. They actually put erasure coding on DVDs and CDs so that if you got a scratch, you could read the remaining bits and still play your music or play your video. We've applied it now to data storage. So in our algorithm, which we call Vid Spread, we figured out a way to store data redundantly without having the overhead of doubling it or copying it or mirroring it, but make it ultra durable. Okay, so effectively you'll have an unbreakable data storage system through this mechanism. So what really makes that possible then is this thing called Vid Spread. Okay, this is the secret sauce here. It is a software technology. Essentially what it does is it encodes data mathematically and distributes the pieces across a huge storage pool. So you can build up a very large storage pool of hundreds or thousands of drives. But what we're doing is sending out this encoded data, mathematically encoded data over the back end. And I want to give you a quick peek on how that works in a simple example here. So let me kind of move ahead. Okay, so this is the kind of very, simplified example. What we're trying to do is store data, right? So this may be, in general, a video object or an image or an audio file. I'm using a simple example of 2 numbers just to make this, easy on the example. What we do is we take the source data, we subdivide it into its pieces. So in this case, 75 becomes 7 and 5. Instead of storing those 2 numbers on disk, we mathematically transform them into a series of linear equations. Okay, so this is math, for high school math, right? X plus y, 7 plus 5 equals 12, 7 minus 5 equals 2, and so on. I can generate an infinite number of these equations. And they're very compact, they're very tight representation. What I do is then I distribute those widely across the storage array. But I have enough of them so that if I lose drives, or if I lose entire storage boxes, or even if I lose a whole data center, I can still bring the data back. Okay, so that's really the key innovation here, is to be able to protect data against lots of failures, protect it against unavailability of a data center or a site, and to make sure that the data is always protected even if these drives fail. So it works in a distributed manner. You can spread things across, data centers on the West Coast, Chicago, New York, Europe, wherever you'd want it to be, and it does that in a very, very reliable fashion. So where are we putting this on? Well, we're putting this on our own storage system called Amplidata. So this is where the encoder runs. It runs on a set of servers that have lots of processing, like dual quad-core Xeons. But the real key is that the encoder sends the data out in a distributed fashion to the storage pool. The storage pool can be as few as 8 modules, or it can be, in practice, thousands. Right? So you can have petabytes or more of data storage. So the use cases that we're finding for this are really driven by video. I think that's a large part of the volume. We've talked to a number of studios that are, of course, doing HD now. I understand the rates of capacity that they need for filming are something on the order of 80 terabytes per day for HD video shooting. So it's multiple terabytes per hour. We've heard anecdotes about Avatar, the movie, requiring something like 800 petabytes overall storage, with all of the raw footage and all the backups and all of that. Even simple TV productions now are into the petabytes of video for archiving of a couple of years of video storage. So this is really the driver here, right, is that data rates are just exploding with high-resolution images and high-resolution video. So we're seeing this in the cloud with online application providers like Kodak and Snapfish and Shutterfly. We're seeing video online, of course, with the social media people and the YouTubes. But really the entertainment people themselves need a place to park all of that data after it's been produced and edited. They traditionally have been putting that on tape, but they'd like something that's more accessible, some spinning media that lets them access the file. So let's say they need to produce a DVD or a Blu-ray or something in the next few months after production. They have an online accessible repository. So this kind of technology makes it possible to do that in a very reliable and very cost-effective manner. So that's something that seems to be gaining good acceptance in that community. So that's kind of the Amplistore story in a nutshell.